Assalamualaikum warahmatullahi wabarakatuh. So we focus to the discussion in PSPM question SK 025 paper 2 2019-2020. So in this discussion we just focus on 4 questions. Question number 1 until question number 4. Okay. So now we focus for the question number 1. It's consider 9 mark for this question. So we read the question carefully. We have the data and this reaction occur between the ethyl methanoid and sodium hydroxide ion. So but this question there are cannot given a specific equation. But according to the data given, we have a 4 several data which is a 4 repetition value, and the first reactant here consider the reaction with the sodium hydroxide. Walaupun dia tak bagi equation, tapi kita tahu dua tabel ini akan melibatkan penulisan rate law kita. So daripada kita ada data initial rate, so we need to consider the concept of initial rate method. Okay, so the first question in question number 1, so 1 Roman, the target question is a determine. So the meaning of determine, we need to show how we find out the order of the reaction, but its focus for each reactant. So who is our reactant? So methyl ethanoid dan juga sodium hydroxide. So what is your first step? So our first step, you must be write down the general rate law equation. So what is the general rate law equation? It shows the relationship between the value of the rate equal to the rate constant times the concentration of methyl ethanoid to the power of x, which is the unknown of the order respect to the first reactant, times the concentration of the hydroxide ion respect to the another unknown. So means x and y. This is our target order we need to find out. So what happened? We need to consider by using the method of ratio. So from here, we are compare from the data experiment 1 over data experiment 2. How we arrange the data, we focus to the general rate law equation. So what happened? We can cancel out the k and the value of the unknown of the x. Finalize, you can get the value of y is equal to 1. So finalize, you need to find out your final mark. So which is according to your conclusion. So it's the conclusion. So the first order is respect to the hydroxide ion because we are target to find out y. Okay, next. Y already find out. So how about x? So in x, we need to compare the data from experiment 2 over experiment 3. So 2.03 here is come from the initial rate value over initial rate value experiment 3, and we substitute the data. Finalize, we can get the value of x respect to the concentration of the methyl ethanoid is equal to 1. So the final mark you must be conclude. What is the meaning for first? What is the meaning of 1? So this is conclude as a first order respect to the concentration of CH3, COO, CH3. So, after we already get the value of x is equal to 1 and the value of y also equal to 1, so we need to write down the specific rate law equation. So, just substitute the value so we can get the specific equation rate equal to the k times concentration of methyl ethanoid to the power of 1 times concentration of OH to the power of 1 also. So basically, this is considered as a 1 mark lah. Only the term is a right rate law equation only. Okay. Next, from the rate law equation, we can calculate the value of a rate constant. So how you calculate it? You can choose any experiment data. So for example, we try to come out the data from the experiment 1. So our rate value is 1.58 times 10 to the power of negative 3 molar per second equal to rate constant times the concentration of methyl ethanoate to the power of 1 and concentration of hydroxide ion to the power of 1. And we can calculate the value of the K you need is compulsory. Okay, so for the last question to cover 9 mark in question number 1. So dia minta dekat sini, how many times we are focused the rate of reaction if the second factor we are considered as a concentration of both reactant are double. So what happened? So we try to consider as a method of the ratio also. So the first here is the the first is the rate law equation without any factor. So this is considered over to the factor kita. So means if our concentration of CH3 COOCH3 first is 1. So maksudnya yang kedua CH3 COOCH3 after we add 2 kali ganda. Sebab itulah kita akan darab dengan 2 kepekatan the first reactant and darab dengan 2 for the second reactant. So next what happen? Dekat rate pula kita letak 1 pemalar. So saya pilih huruf N lah untuk detect. What is the value for N? So kita boleh detect dekat sini. We can cancel similar. Okay. And then yang hanya tinggal sahaja 1 over N equal to 1 over 4. So what happen? Kita akan darab silang. Bila you darab silang, kita akan dapat N equal to 4. Bila N equal to 4, we can make a conclusion. If the concentration of the both reactant are double, what happen to the value of the rate? So N ini dekat sebelah rate yang kedua. So kita boleh tahu rate increases 4 times. Question B. Okay. This question B according to the diagram, energy profile diagram. So we read the question together. The decomposition of reactant ammonia to produce nitrogen, hydrogen with a specific temperature. So mean this is our target condition lah. Okay. So this is study on the surface of the two different catalysts. First is tungsten, second is osmium. So the energy profile diagram already given. So according to the figure 1. So apa soalan yang dia nak? In question number 1, there are state which catalyst. What happened? We need to choose which one is a better for the reaction. So which one is the better for the reaction? You must check again the diagram. So according to the tungsten catalyst, we can trace the EA value or activation energy value is a lower compared to the osmium. So mean EA for the tungsten is a lower than EA in osmium. So what happened? So by using the tungsten, it will provide another pathway. So we can conclude that the rate of reaction should be will increases. So which one the better rate of reaction? It should be tungsten. You sebut je tungsten, you akan dapat markah sebab soalan dia adalah which. And then kita explain kenapa based on to the concept of the catalyst. So we can state tungsten is a catalyst which is better for this reaction. Why? Because the presence of a tungsten in the reaction, it will increase the rate of reaction. So dia buat apa? Provide alternative pathway with lowering activation energy compared to the catalyst osmium. So for this question B, it's cover 5 mark. So bila 5 mark, for first question, we have maybe 2 mark. And the second question may be 3 marks. So what happened for the question B here? They are given. The value of the activation energy by using the tungsten catalyst is 163 kJ per mole. How many time faster of the reaction? Means dia minta rate yang seterusnya apabila faktor kita berubah temperature. So means kita ada EA value is equal to 163 kilojoule per mole But we have the next factor T2 550 degrees Celsius. But before we consider for this question, so sorry, this is question number 2. Okay, so we can identify the specific temperature before. Okay, so from this profile diagram, our 450 degrees C is our T1. So we label T1 is 450 degrees C. So what is the keyword for this question? If the temperature is changed, what happened? We can have the value of a new K2. So T1, K1. So disebabkan kita tak ada nilai K1 and K2, we need to find out the ratio by using the formula ratio K1 over K2 equal EA over R times 1 over T2 minus 1 over T1. So from the data, our target find out first K1 over K2. So when we substitute the data, okay, our EA and also your R constant, temperature must be in Kelvin, we can get the value of ratio K1 over K2 is 0.037. Tapi kita nak apa? Kita nak cari rate yang kedua. Apa jadi apabila temperature itu meningkat? Tetapi kita hanya ada ratio K1 kepada K2. So, bila T kedua meningkat, bermaksud K2 juga berubah. So, nak buat apa? So, K1 over K2 is equal to the 1. So, kita kena terbalikkan this ratio. So, hence, the ratio K2 over K1. Kenapa kita nak fokuskan kepada rate yang kedua? Okay, so 1 over 0.037. So, this is equal to 27. So, we can make the conclusion, the value ataupun the process rate yang kedua adalah 27 ataupun 27 times rate 1. So, we can conclude that the rate 2 is 27 times faster than rate 1. So, for this question, maybe it cover 3 marks because the question B cover 5 mark. Question number 1 maybe 2 mark and question number 2 is a 3 mark. Okay, let's continue to discuss question number 2. Okay, so what happened to 2A? So, this covers 6 mark. We read the question together. We have the ethanol and a formula already given. But these ethanol are produced by the process fermentation by using the sugar cane while it's used as an alternative fuel with the replaced by the petrol. But the data starting from the second statement. So we can get if we have 1 gram of ethanol was burned, which is a process combustion, in calorimeter, which is a bomb calorimeter, the total heat capacity for calorimeter is 11 kilojoule per degree Celsius. Mean this is C calorimeter. Okay, and the temperature of the calorimeter is and its contents increases from 25 degrees Celsius to 27 degrees Celsius. So, dia kata dekat sini 6 markah. Kat mana kita nak cari 6 markah tersebut? Okey, soalan pertama. Okay. Write balanced chemical equation. So, this balanced chemical equation, we must consider together the phases. This is a compulsory. So, bila dikata guna bomb calorimeter, this is belong to the process of combustion. So, who is your reactant? Ethanol. React with the excess oxygen, produce carbon dioxide and water. So, you just balance the equation and the phases is compulsory. So, dia maybe dah cover 1 markah dekat sini kot. Okay, it's okay. So, we proceed to the second question. Okay, in question number 2, we need to find out, calculate the enthalpy combustion of ethanol per mole. What is the meaning? Oh, dia minta enthalpy combustion ethanol. CH3, CH2, OH in unit kilojoule per mole. So what happened? We know that by using calorimeter, so our system is isolated system. So if isolated system, we know that during the reaction occur, no heat release to the surrounding. So we can match the relationship between for this part. Means during the process of combustion, heat released by the reaction is equal to the heat absorbed by water plus heat absorbed by calorimeter. And when we are traced from the equation, we do not have any data for water. So what happened? We can cancel the heat absorbed by water. So now the heat of reaction only focus by absorbed calorimeter sahaja. So next we substitute the data and finalize we can get the heat of reaction is equal to negative 29,700 joule. Tapi dia nak enthalpy combustion. Apa maksud enthalpy combustion? Enthalpy combustion must be heat release. So we already get the negative sign here. So what happened? 1 mole substance. Who is our substance? Ethanol. Completely burned in excess oxygen in their standard state lah ataupun their stable state. So what happened here? First thing, by using the mass data, we must be calculate the number of mole ethanol. So next, we compare stoichiometry 0.0 to 174 mole ethanol released to 9700 joule. So what happened if 1 mole from definition? So we can get negative 1366,200 joule. So we can make conclusion the unit in kilojoule. Enthalpy of combustion ethanol equal to negative 1366.2 kilojoule per mole. So unit kilojoule per mole is compulsory. So we focus for the next question. For B, this is a concept of Born-Haber cycle. So it also covers 6 mark. So the Born-Haber cycle given for the calcium sulfate, but this cycle not draw based on to the scale. So the diagram already given. Okay, so what happened for the question? Question number 1, name the enthalpy number 7 and number 8. So we continue with this. We find out where is the enthalpy number 7. So it changes from the gaseous ion, cation, gaseous ion, anion to produce 1 mole of the compound. So this is a lattice energy. Okay, and then enthalpy number 8 from the element produce 1 mole compound. So this is enthalpy of formation. So we can write your answer. Enthalpy 7 is lattice energy calcium sulfate, and number 8, enthalpy formation of calcium sulfate. Okay, next we try to identify what is the species of the X for the enthalpy number 5. Okay, where's the location enthalpy number 5 here? So this is enthalpy number 5. So dia nak cari X. So when we are traced, this is arrow downward. So from what? From, okay, calcium does not change. So the changes only sulfur gases. What happened to here? So this is a process of atom accept electron. So this is the process electron affinity. So electron affinity, so the X should be S minus ion. So the phases should be gases. So we can write the species of the X is S minus ion. Okay, so we proceed to the question number 3. We need to calculate the value of delta H6. Okay, kita check balik. Mana delta H6? So we know that macam mana nak kira? Has delta HX is equal to the addition all the enthalpy in our diagram. So, jadi kita masukkan sahaja. So, finalize, you rearrange. Kita akan dapat enthalpy ke-6 adalah positif 539 kilojoule per mole. This is belong to the second electron affinity of calcium sulfate. Okay, for the last question for the 2B, which is the lattice energy for calcium oxide larger or smaller than CAS? So what is the factor for here? So we try to indicate CaO versus CAS. So calcium ion are same. So our focus is 2 minus and S2 minus. So means sulfur and oxygen are belong to the same group. So what is the factor? Ionic size. So the first statement we need to compare the ion for the oxide ion O2 minus smaller than S2 minus. So bila smaller kita kena tengok the distance separation between oxygen ion ataupun O2 minus ion and Ca2 plus ion shorter than Ca2 plus and S2 minus. So what happened? The smaller the shorter ataupun if the distance between ion O2 minus and calcium ion shorter, so the attraction between their ion stronger. So bila stronger, the value of the lattice energy, so we can get the magnitude of lattice energy calcium oxide is larger than calcium sulfate. Okay, last question for the question number 2C. Dia minta kat sini 2 markah. They are given the thermochemical equation dan all the 3 equation given here, they are enthalpy formation. So, bila 2 markah, kita boleh trace dia punya method dia macam mana. Dia minta dekat sini. Determine the enthalpy changes for distribution. So, dia nak delta H. So disebabkan all the data from the equation is enthalpy formation, we can calculate the value for this enthalpy by using the summation of the enthalpy of the product formation minus summation of the enthalpy for the reactant. So bila kita masuk nilai, finalize, kita akan dapat negatif 899.2 kilo joule without per moles because this equation not belong to the specific equation of the equation of the jenis enthalpy. So ataupun kita boleh guna konsep Hess's law. Bila konsep Hess's law kita kena tengok, okay? CAS ada dalam equation nombor berapa? Oh, ada dekat equation nombor 3. So, apa nak buat? So, kita akan reverse for this equation. Kalau you tak nak guna calculation product tolak reactant. Tapi nak guna formula ini, syarat enthalpy dia mesti all of them are formation. Okay? So, kalau tak formation, kita kena guna konsep Hess's law. Okay, kita dah selesai jumpa data. Tetapi bila kita reverse for 3 equation, apa jadi? Sign ni akan berubah jadi positif. And then kita cari oksigen, ada dua-dua. Kita let dulu. Kita cari carbon dioxide. So, carbon dioxide exists in equation number 1. So, perlu buat apa-apa? Tak perlu sebab carbon dioxide in equation 1 already as your product in 1 mole. So, this is product 1 mole. So, settle. And finalize, SO2 kita jumpa dalam equation nombor 2. So, nak buat apa? So, this overall equation time 2, including the data. So, finalize, kita akan dapat jawapan yang sama. Okay, so question number 3. 3A cover 6 mark. So, bila 6 mark, we read the data carefully. The standard reduction potential for the 3 element copper, chromium, and nickel ion are given below. So from the 3 data here is directly from the standard reduction potential data. So the question here, arrange metal. Okay, dia nak metal, dia tak nak ion, nak metal, which is, this is lah our product here. According to the increasing strength of reducing agent. So, bila reducing agent, we need to rearrange for this equation based on to the process oxidation. So bila proses oxidation, our reactant should be as our agent reducing. Tapi which one should we choose? Okay, the higher the reducing agent is referred to the smallest value of standard electrode potential. So we can rearrange here. The lowest ataupun the lowest strength in the reducing agent adalah copper because a more larger value, and then followed by nickel, and the higher is chromium metal. Okay, next question, we need to determine the reaction. The reaction given either spontaneous or not. Tetapi under standard condition. Bermaksud dia nak apa? Kita boleh kira by using the value E naught cell. So in our E naught cell, in the formula, E naught cell equal to the E naught cathode minus E naught anode. The equation already given fully ataupun overall equation. So dalam soalan ni dah bagi equation Cu2 plus aqueous, okay, tambah chromium plus Cr solid produce Cu solid plus Cr3 plus aqueous. So you must be identify who is your cathode and who is your anode. So bila kita trace oxidation number copper decreases from positive 2 kepada kosong. So dia adalah cathode. So kita boleh kira terus by using E naught cell equal to E naught cathode minus E naught anode. Substitute the data so we can get a positive 1.08. So we can conclude that a positive sign, this is a spontaneous reaction. Okay, question number 3. Explain what will happen to the chromium container bekas chromium digunakan to store the copper to sulfate solution. So means from the question number 3, we have the container chromium and we fill up the solution copper to sulfate solution. So what happened? So bila what happened, semestinya chromium, when we refer to the value standard electrode potential value, so chromium is a more reactive metal. Okay, because this is easily to oxidize. So when it become the container to store the copper to sulfate solution, so this chromium will akan ambil alih tempat Cu2+. So what happened to here? We can make a conclusion bila kita store copper sulfate ke dalam chromium container, karakter chromium dia adalah reactive than copper. Kenapa? Kita boleh tengok daripada nilai standard reduction potential value tadi. Okay, and then, so apa berlaku? Chromium can displace the copper from the copper to sulfate solution dan dia akan menghasilkan chromium solution. So target dia adalah what will happen. So maksudnya apa yang kita jangkakan. So what happen? Chromium container will dissolve, finalize, copper metal will form because berlaku displacement daripada chromium ambil tempat copper. So finalize, kita boleh hasilkan copper metal and intensity color of the copper sulfate solution will decreases. Okay, so question 3B. It's cover Fullmark only. Okay, so this is a application question in electrolytic cell. This is a process zinc plating. Is important means in corrosion protection. One of the possible way in which can achieve through the electrolysis. So electrolysis jenis apa? Electrolytic cell. So how many gram zinc can deposited? Di manakah zinc will deposited? So it occur at cathode. Okay, and the current value already given and the time taken is 1 hour. So what is our first step? You must be write down your half cell equation at cathode. So bila kita cathode, kita tahu this is a process reduction. So zinc ion accept electron, produce zinc solid. So zinc solid inilah zinc solid deposited at cathode electrode. So in equation, our relationship is between the product of zinc form and also the number of the electron flow. So by using the formula, the quantity of the charge Q equal to the IT, substitute the data. Remember, our T must be in second. So we can get 4320 coulomb. So this is our quantity of the charge flow when we want to produce a zinc solid deposited. Okay, so kita nak cari mass. Bila nak cari mass, kita kena compare lah. Daripada theoretical, dia ada 2 elektron. So, bila 2 elektron bersamaan dengan 96500 times 2 coulomb, equivalent to 1 mole of the zinc. But in experiment, we just have 4320 coulomb. So, finalize, we can get the mole of zinc is 0.02202238 mole of the zinc. So, boleh jumpa mass? Boleh by using relationship with molar mass. So, the mass is 1.464. Okay, done question number 3. So, we discuss question number 4. Okay, question number 4, we consider only 3 mark. So, bila 3 mark, kita melibatkan organic compound. Okay, propane undergoes free radical bromination. So, propane is alkane. Bromination process, we know that this is our reagent used, the presence of bromine in inert solvent. The keyword of free radical, the condition, the presence of sunlight. Okay, this reaction produce compound A. Determine ataupun draw the intermediate product form and the structure of the A. So we know that propane consists of 3 carbon atoms. So CH3, CH2, CH3 reacted with a bromine molecule, the presence of inert solvent and UV. So kita boleh trace what is the product form A. So the more major product form. So Br attached pada carbon nombor 2, kita akan dapat 2-bromopropane. Okay, how we answer the concept of intermediate form? So means the answer should be radical species. So be radical species, we need to show the process how the radical carbon form. Okay, so the intermediate product is starting by using the concept of bromination. So by using a bromine molecule, the presence of a sunlight. So what happened? So the half electron and 1 electron are given to the bromine, another one given to the bromine. So this occur homolytic cleavage and we can get a bromine radical. So the next step, bromine radical will reacted with the propane molecule. So the bond cleavage occur pada carbon nombor 2. So one of the electron including hydrogen can form covalently bond with the bromine radical. So another one electron from this bonding here given to the carbon, finalize we can get the carbon radical. So this is the process how the intermediate product form. Okay, so the last question number 4, it's cover only 7 mark. Okay, sorry, 4 mark. So dia melibatkan hydrocarbon C6H12. Okay, why I label alkene? Kita read the question carefully. Read 1 mole of hydrogen gas. So this is our reactant, hydrogen. Over platinum, catalyst kita produce C. So siapa C? It should be alkene. So kita boleh trace one step reaction. Okay, the process of oxidation of the B, so B is the alkene, will produce a carbon dioxide. So dia menghasilkan carbon dioxide and carboxylic acid D. Okay, so draw the structure of B, C and D. Name the C simple chemical test to differentiate B, which is the alkene, from C, alkane. Okay, kita go through dulu. Where is our first step? Okay, so we know that according to the oxidation process, okay, by using a strong oxidizing agent, carboxylic acid form and carbon dioxide also form together. So means that your carbon-carbon double bond in the structure B allocate at the end of the chain. So we can trace structure B have the carbon double bond at the end of the chain, mean carbon number 1 and carbon number 2. So the raised carbon is similar. So we have a 5 carbon total. Okay, so this is the structure of B. So when this structure of B undergo process oxidation, the bond cleavage occur. So this side will form carboxylic acid. Why carboxylic acid? Because we use a strong oxidizing agent. And another side here can form carbon dioxide and water. So kita boleh lukis, kita punya structure B is alkene, carbon-carbon double bond at the end of the chain. So structure C process electrophilic addition reaction toward to the carbon double bond. So the structure of C is alkane. And finalize, kita boleh trace structure D is propanoic acid. So we have the propanoic acid, pentanoic acid. Penta is 5 carbon, 1, 2, 3, 4, 5. So pentanoic acid. Okey, sekarang ni kita nak bezakan B kepada C. Alkene versus alkene. Apa nama test nak bezakan dia? What is the test to detect carbon-carbon double bond? So basically the easier is Bayer test. So dia nak namakan sahaja. So Bayer test is using potassium permanganate solution in the condition of the basic but in a cool condition. So done for Fullmark. So enough for today. Thank you.